Yeah, sure. Good morning, everyone. Thank you so much, Jose and TIS Summit, for inviting me. My name is Swapnil. I'm co-founder of Uravu Labs, and we are a Bangalore-based startup. And a lot of my previous colleagues have spoken about reuse, recycle, and a lot more, recreation. I'm going to talk more about renewable, and especially in the case of water, how we can, makes water more renewable. Sure. Thank you.
I'm very happy that Swapnil was with us in 2017
Correct.
at the TIA Summit at the World Trade Center. Um, I'm not sure if it's in your presentation that now you raised your seed round or Series A?
Seed.
Series A, okay. So it's very interesting to have him once again back at TIA Summit.
Sure.
And at that time, he presented a very, very interesting concept, and those videos are also online. And I think we are happy to have you back, and over to you.
Yeah, thank you. So I would like to just add to that Uravu journey, and I think TIA Summit 2017 is when we actually started, and now post 5 years, I'm really happy to be back here. So since 2017, Uravu has really grown into like a large team. We're almost 60 people from various diverse backgrounds, working on R&D, engineering, business development, design, as well as sustainably overall. And we have also been, actively supported by uh, investors as well as stakeholders from all around the globe who believe in our mission of renewable water. And the problem we are really looking at is, as an industry, especially the beverage industry, consumes a lot of water. It almost consumes 1,500 billion liters of water annually, and more than 45% of that is coming from groundwater sources. Now, you may think, like why groundwater is some resource which needs to be have a sustainable alternative. So why is that? Because groundwater in itself is a non-renewable resource. It almost takes 1,400 years to replenish naturally. 1,400 years is actually a lot. Groundwater has been, accumulating in our Earth's crust over many billions, millions of years. But then we are depleting at very fast rates. So we need a more sustainable alternative to it, and that's where Uravu comes in. And in this whole beverage industry, which is using almost 1,500 billion liters of water, it's globally a $2 trillion industry with many categories, be it in packaged water, alcoholic drinks, or non-alcoholic drinks. But there's no renewable water option as of now. So Uravu takes inspiration from technologies like solar PV and wind, which have enabled a more decentralized and cleaner energy transformation. And Uravu is trying to bridge that gap with a similar renewable water option, and specifically tailoring it for the beverage industry. So, like now I have talked about renewable water. Many of you guys would be thinking what exactly is 100% renewable water. So there are two aspects to it. One is we source water from moisture in the air. Now, moisture in the air is almost a limitless source of water. Why we say that? Because quantum-wise, it's almost 6 times the water we have in all the world's rivers combined. And the good part is that due to the Earth's natural cycle, in just 8 to 10 days, this water vapor replenishes naturally. And this is an infinite source which we are not tapping into. And second important part is whatever energy is needed to harness this water from the air should also come from renewable energy sources. So which in our case is predominantly solar. It could also be biomass or waste heat from industries. And to do that, we use something called as desiccants. Desiccants are water vapor loving materials which are commonly, for example, one example is silica gel. So when you buy a footwear or pair of electronics, you will see a small pouch of silica gel. The property of these materials is they rapidly absorb moisture when air is passed over them. And there are similar other desiccants like calcium chloride, lithium chloride in liquid form. So how the process works is, suppose you start with 10 kgs of material and you pass air over it, in about 2 to 3 hours, it will become almost 12 kgs. That means it has absorbed 2 liters or 2 kgs of moisture from the air. And then we heat it up to about 70 to 80 degrees Celsius. And in this case, it releases the earlier absorbed moisture, which we are then able to condense to form fresh water at just normal ambient temperatures. So the energy for all this is primarily heat, driven rather than consuming a lot of electricity from our grid, and it enables us to form very high quality water with just using a simple material and limitless energy like solar. So when we have these both key aspects of using a water-friendly source and renewable energy, we get renewable water. And so this is how the whole system is architected. We have fans which suck in air from the ambient air, and before that they pass through air filters which make sure that pollutants or air dust particles don't enter the stream. And then we heat it up, this desiccant, using mainly solar water heaters. In Bangalore, we see solar water heaters are pretty common. And these are basically tubes which are collecting heat from the sun, and then we are transforming that to a desiccant chamber which is producing the water. And once this water is produced, we pass it through a ozonization tank which makes sure if there is any contaminants, those get removed. And then also add ultrafiltration membrane and a mineral cartridge. Why mineral cartridge? Because air necessarily doesn't have any minerals or ions which might be needed for the human body for consumption. So to make it portable, we have to pass it through a mineral cartridge. So in this way, the whole system enables us to capture moisture from the air and using solar energy then transform it to very high quality drinking water. And if you look at the whole landscape of water from air, this is not a very new technology. Companies have been doing it all over the world. There are almost 200 companies, if you look at how many companies are registered overall. But then 98% of the companies are working on something where they use an air conditioner to make water from air, which is essentially you have a very cold surface, which when you pass moisture over it, it starts condensing that water. So it becomes a very energy intensive process and highly reliant on very high humid conditions. So the cost of water becomes really high. But today they are scalable in nature. So suppose you want 10,000 liters of water per day from atmosphere, there are machines which can deliver that. Then there were companies who came up with a renewable option. There's a company called Source Global from the US. What they do is make a 5 liter per day panel, which is essentially looks like a solar panel, and they're able to extract around 5 liters of water per day. So although they are renewable in nature, they remain non-scalable because if you want more water, you have to keep duplicating these units without any further reduction in cost. And what Uravu has done is come up with a renewable as well as a scalable option where we bring the cost down to as low as just 3 to 4 US cents per liter. And this is what we have enabled overall. The idea is that once we are able to scale up to sufficient volumes, we'll have a standard shipping container of 40 feet by 8 feet by 8 feet, which will be able to provide almost 4,000 liters of water. And you can pair it with any kind of energy sources available on site. So it could be solar, which could be the ideal option. But if you have biomass waste on some locations, you could have waste heat in industries at 70, 80 degrees Celsius. And if you already have a solar PV or wind kind of solution which is giving you renewable electricity, that could also be used. So we started with a 100% renewable and scalable option, but now we are also an energy agnostic solution. And the idea is that these kind of units could be supplied to a lot of beverage companies, be it the Pepsi's, Cokes of the world, or AB InBev, Carlsberg, so many companies which are using water as a core ingredient to make their beverages. And we supply them these water and we're able to reduce 2 to 10% of their freshwater requirements in any of these beverage companies. And we have already started working with customers like AB InBev. What AB InBev did a couple of years back in the European market, they launched Budweiser with trademark which says brewed with 100% renewable electricity. But electricity is not something tangible in the hands of consumers. You won't know that it was actually brewed with 100% renewable electricity. But when we told them that you could make a beer bottle and say brewed with 100% renewable water, because in hands of consumers, beer is almost 92% water. So that, that helped us get an order with them. So we're already doing a pilot with AB InBev, very close nearby. They have an office in Ashok Nagar. So there we have installed, and we also met there a lot of their global teams. And we are quickly scaling up a solution to be installed in one of the breweries in Mysore. And we are also working with a company called Radico Khaitan. They make many popular products like Magic Moments vodka, Jaisalmer gin. So there again, the idea is that by replacing the groundwater which they currently use to make their products, they can shift to a more renewable water supply using Uravu's solution. So we envision that all kinds of beverages could essentially become more sustainable and renewable in the future if they could replace their core ingredient, which is water, with a more renewable option provided by Uravu's solution. And if you look at the overall impact of these solutions, there is definitely a social impact when we are conserving the groundwater. But from an environmental impact as well, for every liter of water we are able to save, we are able to produce a renewable solution. We are almost saving 2 liters of groundwater. Because what essentially happens is the baseline technology is reverse osmosis, which actually rejects a lot of water, which ultimately gets wasted and goes back to groundwater unused. And there's a lot of carbon emissions which come with the pumping as well as filtration of these using technologies like reverse osmosis, which Uravu offers a more zero waste, zero carbon solution to address that. And these are the kind of products we are imagining. 20 liters per day is our current product, which is going to support low volume requirements, especially for drinking. But 200 liters per day and then 2,000 liters per day will be able to support more commercial and industrial applications as we move forward. So this is how 20 liters per day looks like. It occupies around 8 square meters on a rooftop and is able to produce water, especially for a family of 4 to 5 could be essentially catering to their drinking and cooking needs. And the 200 liters per day could be, either put on, say, a rooftop of a tech park or even a hotel building, where instead of getting water from plastic bottles, you can just essentially make water on your rooftop and then serve it in glass bottles, refillable glass bottles. And the main idea overall, as we scale, is not to limit ourselves to just the beverage industry, but to essentially have large-scale units which can cater to volume requirements of entire communities. So in Indian context, there is always a well at the center of the village, which is kind of providing water to these communities. But we imagine that in future, there could be a large-scale Uravu plant, which can then supply water to a lot of these communities for their everyday drinking needs. So that's how we plan to scale and then grow this renewable water mission. Thank you so much.